Okay, so how is everyone today? Good, I hope? Lovely. Any questions before we get to business? Any questions? Okay. So today is Valentine's Day. Last time we left where we had just begun talking about distance, so we'll retread that ground. So on the real line, the real line is visually depicted with with a horizontal line, and the convention that we use in math class is essentially always that it increases to the right. At any rate, you can always tell because the arrow indicates the direction of increase. Suppose we select 2 points, x1 and x2. x1 and x2. What we would like to know is this measurement right here, which we'll call D. Okay, so the the distance D from x1 to x2 is what? So I'd like a formula D equal whatever. So what's the formula? Okay, this is nearly right, but it's not right. So the reason why it's not right I'll explain with an example. Suppose that it is the case that if you wanted to drive to Houston, which is a big city south of here, suppose it takes 4 hours to drive to Houston, which is approximately correct. So the amount of time that it takes to travel from Dallas to Houston is 4 hours. Then is it the case that the amount of time that it takes to travel from Houston to Dallas is negative 4 hours? Absolute value, right? Good. So you need the absolute value so that the distance from point A to point B is the same as the distance from point B to point A. That being said, there's a different measure that we'll calculate. The signed distance from x1 to x2 is what was initially offered, x2 minus x1. So the signed distance is always the final minus the initial. So it's called signed distance because there's no absolute value there. In this case, In this case, the way you denote that is with delta x. So a brief aside, not really part of this definition, but this is just a reminder of the way things are. Delta is Greek delta. You know, the Greeks, they want to be able to write things too. They've got an alphabet, and they don't use the same alphabet as we do. They use the Greek alphabet, as it would happen, and the Greeks, many of their sounds are the same as sounds in English, and letter delta is phonetically equivalent to English D. Okay, so then the reason for the usage of delta x here is that this is the difference in the x's, and delta difference. Fine. Also, I want to be perfectly clear that delta x is a single object, which is to say is a single item. So it is not delta multiplied by x. And for the time being in this course, this kind of thing would be nonsense. Okay. So I'm going to leave just a little bit of vertical space here so that I can come back. And then I'm going to do the next thing. So that's the line. For the plane, R2, we'd also like to be able to talk about distance. So suppose we select 2 points on the plane, like those 2 points. Yes?
Hi, excuse me. May I have a moment real quick?
For excuse me, for what?
We have a special delivery for Bethany from Maddie D. Rad.
I'm sorry, but it's going to have to wait.
Oh.
I'm very sorry.
Okay.
Thank you. I'm surprised. Really, because there's 20 of y'all or 30 of y'all in here. Each of you are literally paying like $1 a minute. I can't, that's like $30 a minute. And I get paid at a certain rate per minute. Unbelievable. Okay. So we want the distance from this point to that point. And the tools that we have at our disposal are that we're allowed to measure horizontally, and we're also allowed to measure vertically, but it is not permissible to measure at an angle. That's just not allowed. I'm not saying that these rules make any kind of sense or anything like that. I'm just saying that those are the rules. So the way that we can do this is that this is a two-dimensional problem, and we'll break it into two one-dimensional problems. We'll take each point and drop it to the first axis. Suppose that we measure and they turn out to be x1 and x2. Fine. Then we'll do the same thing and take the points to the second axis. Suppose they turn out to be y1 and y2. Okay. So we can compute the distance between on the horizontal axis, and we can also compute the distance on the vertical axis. And because this is a rectangular coordinate system, you should be able to tell me that angle right there.
Which one?
This one right here. It's a right angle. It's a right angle because this is a rectangular coordinate system. And what I'd like for you to observe is that now that we've drawn these helping lines, there is a right triangle. And we know lots of stuff about right triangles, so that's going to come into play. What is the length of the base of the triangle? So it's not quite delta x, it's absolute value of delta x. So I'll write absolute value x2 minus x1. So then what is the length of the height?
Absolute value x2 minus x1, or y2 minus y1.
Very good. So now we have a right triangle. We know two of its sides, and we want to find the third side. So specifically in right triangles, the longest side is called the hypotenuse, and the other two are called the legs. So we know the legs, and we want the hypotenuse. If only we had some kind of formula that would relate all those things. Oh yes, we do. A Greek, the Pythagorean Theorem, which is presumed knowledge for this class. The Pythagorean Theorem tells us that the hypotenuse squared is the horizontal leg squared plus the vertical leg squared. I'm going to make a minor simplification. I'm going to say that this is d squared is equal to x2 minus x1 in parentheses squared plus y2 minus y1 in parentheses squared. So this modification I made is I dropped the absolute value. Is that a permissible thing to have done?
Seems like it is.
Okay, very good. Suppose that x2 minus x1 were negative 5. That's conceivable. If we were doing the one on the top, then we'd have a negative 5, we'd compute absolute value to get 5, and then we'd square to get 25. If we were doing the one on the bottom and x2 minus x1 were negative 5, then we'd just forget about the absolute value, square the negative 5, and get what? 25 again. So it is permissible to drop the absolute value in this circumstance. So the absolute value is dropped because we're squaring. Dropped because we're squaring. Then we can solve for d. D is the square root of x2 minus x1, square that, plus y2 minus y1, square that. And then a slightly different way to write it that's a little more friendly on the eyes. Yes?
So you took the square root of the absolute value. The reason why you got that last answer d equals square root of. Because I'm trying to figure out where the square root came from in the last part.
Well, it's because on this. So here's this. On this equation, we want to solve for d. We want to get d by itself. D is not currently solved for because the left-hand side is d squared. We want the left-hand side to just be a d. And when the squaring changes from left-hand side to right-hand side, it becomes square root. Okay. So this could be written in a slightly more compact way. As follows, you could say that d is the square root of, and now instead of x2 minus x1, what can I write that's just barely more compact? Delta x, right? I could say that this is delta x squared. Little nicer on the eyes. And then what could I write for the other one? Delta y squared. At any rate, this formula, the distance formula, is something that from now on is assumed to be committed to memory. So I left myself some vertical space up here. The reason why is I'd like for you to observe the formula. I wish it was. Can we see them both? Yeah, no, not really. So the formula for distance on the line looks like this. And then retroactively, we could make it be d is absolute value of delta x, the absolute value of the sign distance. Now that looks kind of weird because in the two-dimensional case we have a square root and squares and things like that. We have square roots and squares in the two-dimensional case, but in the one-dimensional case it looks like that. To my eye, that's a little bit sad, because why should it be the case that the two-dimensional answer is so different than the one-dimensional answer? Well, as it happens, they're actually not that different. I'd like for you to recall from the opening weeks of the course that we very carefully noted the following. What is the square root of x squared? Not x. It's absolute value of x. I guess we didn't note it carefully enough. So remember that when you're doing the nth root of x to the n, and this is an example because square root is radical 2, so this is second root of x to 2. A different example would be like 10th root of x to 10. When you're doing that, and you're dealing with an even radical, then the absolute value shows up. So the square root of x squared is absolute value of x. But the cube root of x cubed is what? Just x. The fourth root of x to 4 is absolute value of x. But then the fifth root of x to 5, that's just x again. Okay, as a result, I could say, well, how about what is the square root of x2 minus x1 squared? What is that? Right, because look at the pattern. So I'm obscuring something. Whatever it is I'm obscuring, we're first squaring it and then computing square root of the result. If I'm obscuring an x, if I'm covering up an x, well, then it would be absolute value of x. If I was covering up a y, it'd be absolute value y. If I was covering a banana, absolute value of banana. Right? So this is absolute value of x2 minus x1. So, as a result, the one-dimensional distance formula can be written as square root of x2 minus x1 squared. Or, if you like, the square root of the change in x squared. But that's kind of a clumsy way to write it, most folks would say, because it can be written shorter like that. That works in the one-dimensional case, but that simplification is not possible in the two-dimensional case because we've got things added up in the radical instead of there just being a one thing. Good. Any question about this?
Yeah, that's, I had to throw the generic statement of you lost me.
You lost me.
kind of feel.
Well,
I follow all of that. I follow all of the stuff in D.
mm-hmm.
I think what you said about whatever's happening after the four.
The connection is, so you agree with the green? You agree with this? From 5 minutes ago?
Yep.
These are the same. As a result, D can be written this way.
Yeah.
Okay, let's have an example of this formula's use. One thing that I'll mention is that the line has distance and signed distance. But the plane only has distance. It doesn't have signed distance, for a reason that's a little bit technical. If you'd like to know the reason, ask me after class. It's one of my favorite things, so ask only with care because you might get an earful. Find the distance from 3, 7 to, how about 11, -2. Okay, so a fairly straightforward request to use the formula on the previous page. All right. So I'm going to do it with the delta x's and delta y's. So recall, delta x, well, it's going to be x2 minus x1, and delta y is y2 minus y1. And the only real trick is to make sure that you take these four numbers and put them into the four positions correctly. So, in particular, delta x is the difference in the x's, and if student is going to make a mistake at this position, they'll subtract these two coordinates. But you're not supposed to do 7 minus 3. Why not?
7 is a y.
Yeah, because that would be the difference of a y and an x. Well, that's not what we want. We want the difference in the x's. So, well, I'll put, it doesn't matter which one you construe to be the first point or the second, in the same sense that the distance from Houston to Dallas is the same as Dallas to Houston. So I'll put this x here, and I'll put this x here. So that would be 3 minus 11, which is -8. So yes, it's negative, but we're going to square it in a moment, so that doesn't matter. Then I'll place the y's. Now, because I placed this in that position, that means that the y must be in the analogous position. So what I'm saying is that this y now has to come to here. And now this y to here. So now I'm going to write something. I want you to comment on it. So the difference in the y's, so there I see a 7, and there I'm going to subtract 2, okay. So how about that? Is that right? Okay, good. So do you observe that, well, I want to subtract some y's, and as it happens, one of them is negative. And the one that's being subtracted is negative. So I want to subtract -2. Well, that mean, eventually that means add 2. So I take the time to point this out carefully because my experience tells me that this is a high probability error for students. okay, to make this error. The reason, in the end, is because of quirks in the human visual system. So my expertise is in image processing and computer vision and things like that. And I can tell you that the human visual system is a marvel. It really is. But there are some very easy ways to trick it. And this is one such way. So what's happening is that in this formula there is a horizontal line, that subtraction there. And then you know that this thing is supposed to go there. And it has a horizontal line in front of it. And what happens is that your eye matches that to that, and then it gets omitted when you copy it down here. It's a high probability error, especially when you're under any stress. So the way to make it to where you're very unlikely to make that error is every time you substitute something in, if you'll put some square parentheses around it, or round parentheses, doesn't matter. If you'll put some parentheses around it, then that will interrupt that quirky part of your visual system, and you'll see it. So, did I put the 3 in? Yep, I did. Did I put the 11 in? Yep. Did I put the 7 in? Yep. Did I put the -2 in? Oh, I didn't. Okay, good. Any question about that? I just bring that up because if I don't hit it pretty hard, then next week the result won't be good. So this is 9. As a result, the distance is the square root of delta x squared plus delta y squared, which is the square root of -8 squared plus 9 squared. So 64 plus 81. So that would be 145. So here and now I'm not interested in simplifying this any further, but on the homework it's going to say express your answer in simplest radical form, which means that I want you to factor out all the squares that are possible to factor out. So for example, the square root of 72, because 72 is 36 times 2, you could factor out a 6. Good. Any question about this?
I was looking back through the notes yesterday. You know what? I'll ask this later.
Okay. Other questions? Okay. So another problem, kind of problem, is midpoint. So again, we'll solve the one-dimensional problem and then use that to solve the two-dimensional problem. So suppose, well, that we have a line, or a copy of the reals, and it's represented horizontally like so. And suppose that we select 2 points, x1 and x2. Midpoint is referring to the point that's exactly in the middle. So this point right here. So we want a formula. So supposing that we call this capital M. I'm not calling it lowercase m because something else coming up soon is called lowercase m. So the midpoint capital M of x1 and x2 is, I'd like a formula, m equal what have you. All right, so let's see if we can do a couple examples. What's the midpoint of 10 and 20? 15. What's the midpoint of -3 and 17? 7. Very good. But I'll tell you that it's quite unlikely. Well, I'll just say this. The odds of you being able to respond that quickly are quite low. most folks were just fine when I said 10 and 15, and then when I made one of them negative, then it's just forget it. I have no idea. Okay, the reason is because the reason is because there's an easy formula to use, and if you know it, then it's quick. And then there's the formula that humans are likely to use if they're not prompted to do something different. So the easy formula is, well, it's just average. So when I said 10 and 20, well, 10 plus 20 is 30, and half of 30 is 15. And then when I said negative 3 and what did I say? Negative 3 and 17, well, what's the sum of those? 14, and what's half of that? 7. It's easy enough to do in your head. However, most folks, when you ask them to compute the midpoint of two numbers, they actually do something different. They do something like this. You say, what's the midpoint between 10 and 20? And the thought goes like this. Well, the distance between 10 and 20 is 10, and half of 10 is 5. And then if I move 5 to the right from 10, I'm at 15. That's what most people do. But it gets all broken when one of the numbers is negative, because then your brain doesn't want to participate. So another way to do this, the way that humans do it when you don't prompt them to do otherwise, is x1, the point on the left, plus half the distance between them. So this is what most folks do in their head, but we're going to use just that one. Okay. So for the plane, suppose we have 2 points, and then we can make the line segment connecting them. Now the desire is to find the point on that line segment that is exactly halfway between them. And again, we have the same sort of very strict rules that we're allowed to measure horizontally and we're allowed to measure vertically, but it is absolutely forbidden to measure at an angle. Okay. The way that we'll work the problem is to solve this two-dimensional problem, we're going to solve 2 one-dimensional problems in the same way as before. So we drop these points down to the first axis. And now that we're on a one-dimensional axis, we can make measurements. Suppose that we measure this to be x1 and x2. Then, because in this one-dimensional problem it is easy to compute the midpoint because we just talked about it above, what is the formula for that point right there? Right. It is the average. x1 plus x2 divided by 2. So now the horizontal problem is solved. Let's solve the vertical problem. So I'll turn the thing sideways because I can't really draw the other way very good. Okay, and suppose that we now make measurements, and this is y1 and y2. So now we have a vertical problem. Is it possible to compute the vertical midpoint? What's its formula? The average of the y's. And now, there's probably enough for you to see what the answer to the question is. So we solved 2 one-dimensional problems. So what's the answer to the two-dimensional problem?
Use them together somehow.
Well, let me ask. What are the coordinates of that point right there?
x2, y2.
I agree entirely. It's x2, y2 because, well, the x-coordinate is x2 and the y-coordinate is y2. So the question is what are the coordinates of that point?
Oh, okay. X1 plus x2 complement.
Very good. So the x-coordinate is the average of the x's, and the y-coordinate is the average of the y's. Very neat. Any question about this?
Sorry.
Yeah?
What was the question you asked to get that answer?
To get this? Or this one?
The green.
The question is what are the coordinates of that point?
Oh.
So what I asked first is I pointed to this one and said, what are its coordinates? Well, the x-coordinate is x2, and the y-coordinate is y2. So now pointing at this one, I hope that the trick becomes clear, is that this one is x1 is the average of the x's, and the average of the y's. If I could draw perfectly straight anyhow. And if we were dealing with, instead of a two-dimensional problem, if we were dealing with a 22-dimensional problem, and we wanted to compute the midpoint of two 22-dimensional points, then the first coordinate would be the average of the first coordinates, the second, the average of the second coordinates, the 17th, the average of the 17th coordinates, all the way down the line.
I think the question is, I'm sorry.
Yeah?
It just looks like there's a lot of work left to do. You know, I think I was envisioning being able to use the variables to, like, create one variable, you know, like combine them somehow. So, I mean, that's just, there's a lot of meat left on that bone. You know? So,
Okay, I think we'll probably satisfy that feeling on the next exercise, I think. Okay, so here's an exercise. A circle is plotted with a diameter. Okay, so now we have to make sure that we understand the usage here. So now I'm going to, in about this much space, I'm going to talk about some stuff that you have to understand before you can understand the question. So this part is an aside. So diameter means different things depending on how it's stated. So when you say the diameter, this means the length of a diameter. And this will be a real number. When you say a diameter, this means a line segment. With endpoints on the circle. Which bisects the circle. So I point this out because usually, well, in the first place, the and a are what parts of speech in English? articles, right? And then this diameter is a noun. Usually the kind of thing that a noun is doesn't depend so sharply on the article, but it does here. So in this case, when you say, concerning a circle, when you say the diameter, so that's the quiz bell, but as it happens, the quiz is sitting on the printer and I don't have it. It's just sitting on top of it. So we're going to skip the quiz for today. Sorry for the inconvenience. So when you say the diameter of a circle, that's talking about getting out a ruler and measuring a distance, measuring a length. But when you say a diameter, the kind of thing that you're talking about is a line segment. So they're two totally different kinds of things. They're related, but they're different. In particular, a circle has only one the diameter, but it has infinitely many a diameters, right? Because we're just talking about a line segment that bisects the circle. It could be anywhere, but all of them have the same length. Okay. So here's the circle. So how about this is, say, so circle, here's a diameter. Suppose that this is the point 3, 10, and that this is the point 8, negative 2. So this is a diameter. The length of it is the diameter. So the request is 1. Find the radius and 2, find the center. So I wrote the in the radius in red because the article has the same thing with the radius in circle. When you say the radius, you're talking about a length, something you'd measure with a ruler. But when you say a radius, you're talking about a line segment that goes from the center to any point on the circle. So concerning request 1, pardon me, what's going to be our strategy? So strategy for 1. What do you think? Okay.
Over y2 minus 1. No. D equals square root of x2 minus x1 times
Okay.
y2 minus 1.
So we could use the distance formula. Would that give us the radius?
What between the diameter?
It would give us the diameter. So we would take the distance formula to compute the diameter. So use the distance formula. to find the diameter. And then we'll follow that up with divide by 2. Is there any question why that's the strategy? It's important to know like the overall plan so that you don't get lost in the pluses and minuses and everything. Okay. So we want to compute the distance between the 2 points. I'll do the same thing that we did on the previous page, or 2 pages ago. I'll compute delta x and delta y. So what's delta x? Right, it's the difference in the x's. And you just need to be sure to, if you're saying that this is the first point, then it's always going to be the ones from this point minus the ones from that point. If you do it the other way, just do it the other way. So 3 minus 8 is negative 5, so that's the change in x. And delta y will be 10, and then what? Plus 2, right? 10 minus negative 2 So that would be 12. So then d is the square root of, well, we need to square those things. So that would be negative 5 squared plus 12 squared. So d would be 25 plus 144 is 169. Huh. That I laugh because, why do I laugh? Because complete accident that it happens to be a perfect square. What's the square root of 13? Okay, so is that the answer? Right, because that's the diameter. We're looking for the radius. So the radius, of course, is half the diameter. So the radius is 6.5. And for those of you who are in shock a little bit looking at that thing I wrote there, well, that's an R. That's how you write an R in cursive. And for those of you who haven't quite caught on to what I'm doing here is that when I write statements, like we're discussing something in English, I write that in block print. But when I'm writing math stuff, I write it in cursive so that you can look at it and say, oh, that's a variable and that's a sentence. Yeah. Well, I'll know what it looks like. I love fonts and everything. Okay, so what's the strategy for 2 then? The midpoint, right? Because, well, here's the circle, and this is a diameter. Because a diameter is a line segment, that means that we could find its midpoint. And, well, that's the center of the circle. Every diameter must pass through the center. Okay, well, the answer is that it will be a point. And what will we need to put in the x coordinate? The average of the x's. And what will we need to put in the y coordinate? Average of the y's. So 3 plus 8, divide by 2. 10 plus negative 2, divide by 2. That's 11 over 2, so that's 5.5. And that one is 8 over 2, so that's 4. Any question about this example?
Why you changed the negative 2 on y to a positive 2?
I did?
Up there, I'm sorry, on your circle?
This?
Yeah, that y coordinate looks like you scratched it out.
No, that's just, I put my hand over it too quick,
okay.
and it got smudged.
So I thought that was going to therefore affect your
8,
result.
negative 2. That's just a smudge.
Okay.
Oh, we are out of time. Okay, that's fine. I guess we'll just deal with it. Okay, have a nice Wednesday.